All right, guys, your essential question for today is, how do we determine the continuity of a function? So basically what happens is, if you have a function, it is either going to be continuous or it's not. It's either one. If it's not continuous, then there's three options that it's going to be classified as. It either can be called an infinite discontinuity, a jump discontinuity, or a point discontinuity. And those are the three that we're going to talk about today. All right, you don't need to copy this down, but let's just go ahead and talk about what makes a continuous function a continuous function. Now, this is not the formal definition, but basically, if you can take any graph and you draw it with a smooth, continuous curve, like your linears and your quadratics, stuff like that, then those would be what we call continuous functions. Basically, if you have a picture and you start drawing it, if you do not pick up the pencil at any point, if it's a continuous, smooth shape, then that's a continuous function. However, if you have to start drawing and pick up your pencil and then start again, then obviously you can see that that is not continuous. So that would be an example of a discontinuous function. Now, the graph of this function can not be traced without lifting your pencil or is not smooth. And so one instant is this rational function. So if I were to show you that right quick, if you were to draw the rational function, remember it's this shape right here, there's that shape. But see, notice in order for me to draw the other half, I had to pick up my pencil and start drawing it again. So this would be an example of a discontinuous function. And specifically, it's actually not continuous right here at that asymptote. So it's discontinuous at x is equal to 0. In other words, it's not continuous right here at the line x is equal to 0. And we're going to talk about more of that in a second. But obviously you can see that that is not continuous. So let's talk about what types of discontinuities there are. And this is what you do need to get down, the three pictures. All right, so the first one is what we call an infinite discontinuity. And basically what happens is, if your function shoots off to either positive infinity or negative infinity, then that is what we classify as an infinite discontinuity. It's going to infinity. Your function is going to infinity. A jump discontinuity is whenever your function goes from one y value to a different y value. And then finally, a point discontinuity, I don't know if you can tell it from the graph, but if you were to zoom in on this, well, I can't, let me show you. If you were to zoom in right here at that point, you see how there's like one little dotted white ball right there? That's what we call a point discontinuity. In other words, the function is not continuous at that point. All right, so those are my three types of discontinuity. So let's talk about how you can prove whether a function is continuous or not. Well, there's something called the continuity test, and it's three simple objectives. So this is how you test whether or not your function is continuous at a point. It has to pass these three things. So a function is continuous at the point if it satisfies the following three conditions. And it's not or. It's got to be all three of them. It can't be just, oh, well, it does one, it does two. No, it's got to do all three of them. So in other words, guys, if it doesn't pass step one, then you don't have to worry about the other two. Because if it doesn't pass step one, you're done. It's not continuous at that point. All right, so here are my three conditions. Your function has to be defined. In other words, guys, what that means is you can't have undefined. Now, think back to 9th grade. What's the scenario when you have an undefined? A zero where?
On top.
Not on top. Close. That's close. On bottom. That's good. That's good. You have an undefined when the zero's in the denominator. So, guys, if you end up getting a zero in the denominator, then that means your function's not continuous, and so you don't have to worry about passing the other two. All right. The second step. The function approaches the same y value on the left, and the right sides, they're approaching the same value on both sides. And then finally, the y value that the function approaches from each side has got to be equal to where it's defined. And so let me give you an example of three scenarios where it fails. And I'll show that to you right now. I'm going to show you a picture right quick. So like here's my picture for number one. I don't know. Well, that looks like I filled it in. Hold on, let me erase that. Let me try it again. All right, let me draw a bigger I'm going to draw a bigger hole. There you go. There you go. So there's that one. All right. Okay. Okay. All right, I'm going to pause the video. All right, so each one of those pictures represents a scenario for 1, 2, or 3. For 1, the function has to be defined. If you notice for number 1, this is not defined. There's a hole right there. It's a point discontinuity. For number 2, the function has to approach the same thing on the left and the right side. Notice that this doesn't. It's a jump discontinuity, right? It's approaching two different things. And for number 3, whatever the function is approaching on the left and right, it's got to be equal to where that function is defined. So this is not continuous because this point is up here. It should be right there. All right, let's take a look at an example. So let's say that I gave you this function right here. I give you the function f of x equals x squared minus 4 over x plus 2. And I want you to determine whether or not the function is continuous at this point. X is equal, well, it's not really a point, but x equals, I want to know if it's continuous at x is equal to -2. And you have to explain why or why not. Well, the first thing I'm going to do is I want to know if my function is defined. So I'm going to put that, is my function defined at x equals -2? That's the question. That's my first question. Is my function defined at x equals 2? Well, how do I test that? All you're going to do is plug -2 into your function. And so here's what I'd have. I'd have -2 squared minus 4 over -2 plus 2. Well, go ahead and look in the denominator, guys. What's this going to give me right there? 0. What's that called? Undefined. So is my function defined? No. So is my function continuous? No, right? So you don't have to go any further. So my function is actually not continuous because my function is not defined at x is equal to -2. That's it. That's as difficult as I'm going to take it for this lesson. So simply plugging in -2 in this case and seeing whether or not your function is defined or not defined. In that case, it was not defined. All right, for your next problem, yeah, this is the last one. It's very short. So it says f of x equals x squared plus 3x plus 6 over x plus 3. There's my function. And you might, guys, you can look at this probably and just answer it. The question remains, is this function continuous at this point? Well, guys, what do you think the verdict is? No. Why is it not continuous, though? Yeah, it's undefined. This gives me 0, so that is undefined, and so that means that it's not continuous at that point. And that's it for